So for the last lesson, we're just going to look at modeling data with sinusoidal function. We're just going to look at one example. In 2011, the Singapore Flyer was the largest Ferris wheel in the world. The table below gives the height of a rider from the ground at different times. So we're going to use our graphing calculators, the same as we did for polynomial functions and exponential and logarithmic functions, to enter this data and come up with the sinusoidal function that models this data. So it's the same process for entering. Go to a new spreadsheet, enter your independent and dependent variables, create a quick graph or a scatter plot, and then find the regression. And you'll choose sinusoidal regression. So Jordy got on the Singapore Flyer at noon and rode it for 4 consecutive rotations. His friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet. When was Jordy level with Yale? So we want to know at what points was he at the same height as his friend who was 400 feet off the ground. So once you've entered your data, then you can get the sinusoidal regression. That's just the equation, which would be h of t, because it's height in feet, time in minutes, equals 246 sine 0.169816 t, or x it will say on your calculator, minus 1.5708 plus 295. Let's just write out the variables here that we know. A equals 246, B equals 0.169816, and we don't know C actually at this point because this equation is in a different form. So we're going to leave that for a second. D equals 295. So we want to put the equation into the form y equals A sine B x minus c plus d. So we need to factor out this value from both numbers here, from this one and this one. So if we factor that out so that that b will be outside of the brackets, we would have h of t equals 246 sine, b stays the same. So we're just taking that factor, 0.169816. What's left is t, and then we're dividing also that 1.5708 by our b value, which gives us 9.247 plus 295. So that c value is 9.247. Okay, that's just a little side note. It doesn't really affect our question for today. What we need to do is figure out at what point will he be at 400 feet, which is our dependent variable, or y. So you're going to use the trace function on your calculator and find that first point on the increasing curve. So as he's going up, where does he reach 400 feet? At what time? So when y, or h, equals 400.32. And remember, this is an approximation, so you want to get as close to 400 as you can. If it's not exactly 400, it's okay. So 400.32 feet. The time t was 11.9. So this is just the first time, and remember, he's going to go around 4 times. So we need to find the period because we want to know all of the times that he's at that height. This is measured t in minutes. So this would be 11.9 minutes. So then to find the period, we're going to take our 2 pi, or 6.28, divided by 0.169816, which equals approximately 37. minutes. So that means each time he goes around, it takes 37 minutes. So after this 11.9 minutes, then he'll be at 400 feet again in 37 minutes. So add 37 again. So the second time around, T will be 48.9 minutes. And the third time around, T equals 85.9 minutes. And the fourth time, the last time around, he'll be at T equals 122.9 minutes. So those are the times he's at 400 feet going up. So when he's coming down, he's actually going to be at 400 feet as well. So we need to do the same thing now for the curve coming down. So now on the decreasing side of the first curve, you're going to find h of 400, or as close as you can, and I got 400.32 again. So at that point, T was equal to 25.1 minutes. So same thing, I'm going to add the 37, the period, 4 times. Add the period 4 times so that you can get each time he's at 400 feet. So the first time is 25.1, the second one, 62.1, and all of these are in minutes. So this is our last lesson. You can do the last practice, which would be practice 5 in your workbook or in your assignment package.